Hello everyone, and welcome to this example recording on nodal analysis, where we're going to be looking at the supernode, and we will be determining V1 and V0 using nodal analysis. So step one, again, we need to identify, do we have a supernode or not? We know that a supernode is when we have a voltage source that's connected between two non-reference nodes. The 24-volt source we can see is connected between this reference node and the ground node, this non-reference node rather, and the ground node, which is a reference node. So this is not forming a supernode. But the 10-volt source is connected between V1 and we can call this node V0, which are both non-reference nodes. So therefore, yes, we do have a supernode. So the first step would be to then redraw the circuit and take out any the voltage source forming the supernode and any element that's connected in parallel with that voltage source. And this is the circuit that remains. We've got 4 amp, 40 ohms, 20 ohms, 25 ohms, and 24 volts. Right, and then we know that we typically have to evaluate V1 and V0 through having a nodal analysis over the virtual node. So we decide current directions. The nodal analysis is going to have to happen within the virtual node, and we say that all the currents going in and going out of this virtual node will give you 0. Right, so we've done the current direction allocation, so we can then do the expression. So we can say going in is 4 amps on this side, and then this side it will be plus 24 minus V0 over 25, and then going out will be V1 minus 0 over 40 and V0 minus 0 over 20. Okay, so the next thing that we would need to do is to get a common factor with all of this circuit. So what we can look at, the common factor here I would think will be 200. 1 goes into 200 times, 25 will go 8 times, 40 will go 5 times, 20 will go 40 will go 5 times, 20 will go 10 times, yes. So then we can say 4 times 200, that will give us 800, plus 25 to 200 will be 8. So 24 times 8 gives us 192. Minus again 8 VO, and that will give us 40 to 200 will be 5, so it will be 5 V1, and then 20 to 200 will be 10, so that will be plus 10 V0. And if we simplify this equation, so 80 plus 192 is going to give us 992, and that will equal 5 V1, and then we've got 10 V0 and 8 V0, so it will be plus 18 V0, and that's our first equation. Whilst our second equation, we consider the voltage source plus minus that is forming the supernode, and the as well as the terminals that it's connected to. So we know this is V1, so V1 sits there, so it's plus minus V1. V0 sits here, so this is plus minus V0, and we're going to be looking at a KVL. The voltage drop over the voltage source is 10 volts. So if we do a KVL, we're going to say, if we move in this direction, we're going to say negative V1 plus 10 volts plus V0 gives us 0. And therefore, we can say 10 is equals to V1 minus V0. And that's our second equation, which we can solve. So we will go to your equation mode, select the linear equation, and we insert our coefficients. So this first set of coefficients is 5, 18, and 992. And the second set of coefficients is 1, minus 1, and 10. This gives us a value of V1 as 50.95 and a value of V0 of 40.95 volts. Right, and this is how we would solve for the voltages V1 and V0 using nodal analysis when we can see that you've got a supernode in the circuit. Thank you for watching this video and enjoy the course.